I've spoiled you guys a lot, so never mind, let me keep spoiling you more. Okay, so I'm going to make a very short video on ionic bonding as well. All right, so now look over here. In ionic bonding, first of all, I'm making a dot and cross model for ionic bonding. Okay, before we do that, uh, the basic that you should know is that what are the charges on different groups. Okay, so if you guys remember, we talked about in the class as well, okay, that we have, let's say, 8 groups. Okay, so remember we earlier talked about it, that let's say periodic table looks like this. Yeah, so the middle thing over here, you have to ignore it completely. Okay, and you have to look at the numbers written at the top. Now a lot of you should know how to read the Roman numbers. Okay, so this is 1 2 3 4 5 6 7 8, like that. Okay, now the charge on group 1 is +1. Why? Because it has one electron in the group number tells us how many electrons are there in the outermost shell. Okay, so if it loses one electron, so the charge is +1. If it loses two electrons, so its charge is +2. 3 Group 3 has 3 electrons on the outermost shell, loses all 3, so the charge is +3. Think about it, that we are having sympathy for this atom for losing the electron, so we are giving it a positive charge. Okay, now group 4 has 4 electrons in the outermost shell, so it has +4 charge. Okay, group 5, now look over here, group 5 is a stealer. Yeah, bad person, bad guy, we have negative feeling for that, so we will give it a negative charge. Okay, so how many electrons it's stealing? 3 of them. Yeah, so we will give it -3 charge. Okay, group 6 has 6 electrons in the outermost shell. Okay, it will steal 2 electrons, so we will give it -2 charge. Okay, group 7 has 7 electrons in the outermost shell, so it will steal 1 electron, so we will give it -1. Now group 8 has 0. Why? Because its outermost shell is full. Rich guy, doesn't want to be look like somebody else. Yeah, so this will neither gain or lose electron. So all of these atoms, okay, they are gaining or losing electron to look like noble gases. Group 8 is called noble gases. Yeah, so they want to look like noble gases. Okay, they want to look complete. Okay, anyways, so now let's do dot and cross model of sodium chloride. Okay, now look, sodium chloride is how, first of all, you'll do the rough work. Okay, as we always do. So you'll write the electronic configuration. Okay, sodium, two numbers will be written over here. I have pasted electronic periodic table at the back of the paper. Okay, so it's 11 and 23. You will always ignore the bigger number when you're considering the number of electrons. Okay, so now it's 11 over here. First shell we know has the capacity of 2 electrons, so we will write 2 here. Next shell we know it has a capacity of 8 electrons, so we will write over here 8. So 8 plus 2 is 10, but the number over here is 11, so we'll write comma 1 over here. Okay, then we look at the periodic table. Sodium is in group 1, so it will have +1 charge. Yeah, so +1 means that we are doing -1 electron. Okay, alright, so then it will become 2 and 8. Alright, now from here you see how many shells does it have? It has, let's say, 2 shells. Okay, where first electron has 2 electrons, next shell has 8 electrons. Okay, let's say we do it like that, then we make the square bracket and we write charge over here. Okay, then we do chlorine. Chlorine is 17 and 35 over here. Again, we'll ignore the bigger number, we'll consider the smaller number. So it is 2 comma 8. 2 plus 8 is 10. Okay, and if it's 17 over here, so 17 minus 10 is 7. Yeah, so we'll write 7 over here. Then we'll look at the periodic table. In the periodic table, chlorine is in group 7. Okay, -1 charge. Okay, so -1 means you do +1, right? Okay, so then it will become 2 comma 8 comma 8. Okay, so now how do you do that? Look, for sodium, if you chose dot, okay, so for chlorine you'll automatically will choose a cross. Okay, so first shell you'll do 2 crosses. Okay, Next shell, you'll do 8 crosses. Okay. Then the next shell, you will do 7 crosses. Okay. So first of all, you'll draw electrons for the neutral chlorine. Okay. Now you'll show that you'll put a dot over here. So basically what you're showing is that, sodium had 1 electron and chlorine had like 7 electrons. Okay. So what you're showing is that this sodium electron is being stolen by chlorine. Okay. So hence it is having a dot in its outermost shell. Yeah. Okay. By drawing this dot over here, you're telling this electron is of sodium. Then you'll put a square bracket over here, and then what is the charge on chlorine? -1. Okay, so you'll put a -1 charge over here, and this would be Cl -1 over here. Okay, now guys, try on your own. Okay, I want you all to try for lithium fluoride. I want you to pause the video, do it, and then in the comment section you have to tell me if you got it correct or not. Okay, so I hope you have tried it on your own. Let's do it together. Lithium is 3 and 7. So this is 2 and then this is 1. Okay, lithium ion, it's 2. Fluorine is 2 and 7. Why? Because it's 7 over here. So it's 9 over here, so it's 2 and 7. F minus is 2 and 8. Okay, so then for lithium ion, okay, we will choose, let's say, a dot. We have 2 electrons over here, 1 number only, that means it has 1 shell only. Okay, plus 1 charge. Then for fluorine, first of all, we'll draw for neutral, 2 electrons in the first shell. Next shell has 7 electrons in the outermost shell. Okay, all right, and then it has 1 electron stolen, so because of which we'll draw a dot to show that this electron is stolen of lithium. Okay, all right, then we'll place a square bracket and then we'll write -1 over here, and then we'll write F minus over here. Guys, a very quick review on the properties of ionic compound. Okay, you should remember a very common question asked even in the board exams is that tell any 2 properties, tell any 3 properties, or they give you the properties and they ask you the reason. Okay, so one of the property is that they have very high melting and boiling point. Okay, wait a minute, very high melting and boiling point. Okay, and why it is high? Because the electrostatic forces, okay, are in between the ions. Okay, let's say positive ion and negative ion is joined by electrostatic forces. So in order to overcome this electrostatic force, a lot of high temperature is needed. Okay, then it conducts electricity, okay, in aqueous. Aqueous means that you add water. Okay, or in molten state. Molten means that you take a test tube, okay, and you heat it so much that it becomes liquid. Okay, so in these 2 cases it will conduct electricity. Then it does not conduct electricity in, wait a minute, in solid state. Okay, and why is that so? Because in the solid state the ions are held together by strong electrostatic forces. Okay, so because of which the ions are not moving freely, and because of which they cannot conduct electricity. Okay everybody, within 10 minutes I have explained you the entire topic of ionic bonding again. All the best for tomorrow.